Hello everybody, and welcome to this example of data streaming in Apache Kafka and Confluent. Today, we're going to be streaming information from a Pac-Man game and seeing how that information stream works on our consumer, which is our scoreboard. We're going to be passing data into two streams from our Pac-Man game. The first stream is called user game. This stream contains all the information of what is currently going on inside the game. Now, that contains the number of lives the user has, the score the user's gotten, and what level they're on. The second stream that the game is going to pass information to is the user losses stream. This stream checks whether a user has lost yet or not. The user losses stream pushes that information into a losses per user table. That information is then further sent and appended into the stats per user table. And the user game sends its information straight to the stats per user table. And in the end, that stats per user table pushes that information to a scoreboard, and we can see what's going on and what the scores are and how things are going in the Pac-Man game. So without further ado, let's begin. Before I proceed explaining and demonstrating how to make this project work, I'd like to give a shout out to Ricardo Ferreira for making this entire Pac-Man application and making it as easy to use as we have it here. For more information, the link to this Git will be provided in the description. Please check it out, and please also check the other amazing applications that you can make with Apache Kafka and Confluent. So, with that aside, it's time to look at what you will need in order to get this project working. So the first thing you need, of course, is the Confluent Cloud. You can't run this application unless you have a Confluent Cloud account. The second thing you're going to need is an Amazon AWS account. Specifically, you're going to need to make an S3 bucket. But don't worry, you're not going to have to make anything in here yourself. All of it is going to be handled by this thing here called Terraform. If you don't have Terraform installed already, you can just install it using these three commands. If you're doing it on Linux, if you're doing it on Windows, you can download this file right here. But this entire demonstration today is going to be in Linux, so I would recommend that you proceed with this installation as opposed to anything else. Now that we have all of this aside, it's time to go into our Ubuntu terminal. And see the installations that we have here. So the first thing we need is Java. So we're going to check what Java version we have going. We have Java version 11.0.13. For this project, we need Java 11 and onwards. So if you have Java 11, it works perfectly. The next thing you need is Maven. So we're just going to check mwn-version. And yep, my Apache Maven is version 3.6.3. Perfect. So now, apart from this, we also need to have Terraform installed. I've already installed Terraform, so I'm just going to click Terraform here. Yep, there we go. And it shows up like so. And lastly, we just need cCloud, which is the Confluent Cloud CLI, of course. And that's about it, really. That's about all you need in order to get this project going. So I'm just going to clear this up right here and just cd into our streaming Pac-Man application. So ls streaming Pac-Man's right there. Cd streaming Pac-Man. Whoops. There we go. So now that we're inside the project, let's actually go inside and look at the contents, because there's a few things we need to make sure before we can actually go on and work with this project. So I'm just going to open up File Explorer here, go to Linux, go to my home, and go into my streaming Pac-Man. So over here, there's a few things we're going to have to check before we can actually move on and work with the project. So inside this config file here, there's going to be a demo.cfg file. If we open this CFG file up, we find that it has our AWS access key and AWS secret key inside. We need these credentials in order for Terraform to be able to provision the resources on our AWS. So where are we going to get our access key and our secret key? Well, it's actually really simple. So if you come over to your AWS, search IAM, There we go. And just click on it. And now once you're here, all you have to do is go into users. Now this is the current user that I'm using to manage everything, and this is actually the user that I've provided to the cluster, or sorry, to the project. And if you wanted to add a user here, you could just click this button to add a user, and you could go ahead and add a username from here. You would want to give it an access key with an access key ID and a secret access key, because that is how you would provide the configuration to the project. I'm not going to make a new user right now because I already have one ready. So we're just going to go ahead and move on to the next requirement. So once that's done, we come back to streaming Pac-Man, and there's another thing in here that we're going to have to do. So within this directory, you're going to see this little folder that says stack configs. We're going to need to double click this and make sure that this folder is empty. If there is a configuration file inside this folder, Terraform's going to pick up this configuration and just start provisioning resources, and that's going to be a very messy situation because it's going to make an S3 bucket, it's going to start charging your account, and it's not going to be doing anything for you. So just make sure that this folder here is empty. Now the next thing we're going to do is we're going to go back into our Ubuntu terminal actually, and we're going to check and see if we're logged into our cloud. So the way you would do that is you would do cloud login -- save. So it's asking me for my credentials here. I'm just going to put those in. And there we go. It's written the credentials to a file, .netrc, and now we are logged in and we're already using our default environment. So now that we're logged into our cloud, let's just go back to our streaming Pac-Man application and chmod the start.sh file, just in case. So I'm just going to do chmod u+x start.sh, chmod u+x stop.sh, and lastly chmod u+x create ksqlDB app. So now that we've done all of this, it's time to go ahead and start the script that we have ready. So we're just going to do ./start.sh. And when you do this, it's going to prompt you to say, hey, there's going to be resources charged on your account if you do this. So do you want to go ahead and do it? And in our case, we actually have to go ahead and do it. So we're going to go, yeah. So this process takes a while. So I'm going to pause the video here and come back when this is all set and run. Okay, so now the code has run its length. So let's see what this code did, and then we can proceed with adding the additional bits that we need to actually make this work for us and then see the magic happen. So when we ran this code, what it did first was it created an environment, it created a cluster within that environment, and then it set that cluster as the active cluster for the current active environment, which it changed over to the new one. And then it made a service account, and it gave that service account all the permissions to all the resources that it needs in order to do the job that it does. It created a new API key here, and it set that as the active API key for this cluster. Now, this part is mostly done. Now it comes down to ksqlDB to do its bit. So when ksqlDB runs, it runs into a lot of errors. It does not run properly, and that's a good thing actually. It crashes and burns, basically. So the reason this has happened, and I've sort of modified it to do this, is because I want to go into the Confluent Cloud and I want to make those streams and topics myself. So what I'm going to do now is I'm going to go over to Confluent Cloud and refresh this page. And now that I've refreshed the page, you can see that the shell command actually made me a brand new environment and already put a cluster inside it. So I'm just going to go into this environment, and as you can see, I've got nothing going on in here. Absolutely nothing. So inside this topic section, I want to add two new topics. So the first one is called user underscore losses. Just like we said that we were going to make up. Yeah, that tends to happen sometimes. It times you out. No big deal. I'll just pause and take us back to that screen. Yep, and we're back. So the first thing we want is user underscore losses. We can create that with the defaults. There we go. And then we go back to topics, add a new topic, user underscore game. Create with defaults. There we go. And now that we have these two topics ready, we can actually go back into our folder, and there should be a file in there which has all the statements we need to run to set up the streams and the tables. So let's go into our project directory here, and we should see a statements.sql file. If we open this up, it already has all the queries that you have to run to set up the streams and the tables. So I'm just going to Control A and copy all of this. Close it and come over to ksqlDB, where you will also find that the app made you a ksqlDB app. So when you go inside here, you'll see the editor here. Just paste these commands in and run the query. There we go. So now if we come over to the Flow tab, we can see that we have exactly the sort of solution diagram that we discussed in the beginning, just ready here in the flow. So now we can go ahead and actually get the game started. But before that, there's still one more thing we have to do. So from here, when you scroll up, you'll see that this command failed, where we allow the service account to read and write to certain topics actually. So what we can do is we can actually copy this over and come down here and write cloud service-account list. And we see that that is our service account 503718. So when we paste that command here, we say, okay, user underscore game, full screen this so that we could see the entire command, and service account 503718. And I'm going to give it all the operations. So I say dash dash operation read dash dash operation write to topic user game. And also dash dash operation describe. So when I do that, whoops, that happened. But as we can see, that is actually saying that on your logical cluster, your authentication failed. What that means is essentially we didn't select the cluster we wanted to work in. So what we can do is we can just write cloud Kafka cluster list. And we see that actually we don't have any clusters, which means we're in the wrong environment. So what we can do here is just go cloud environment list. And there we go. It shows us both our environments. And we want to use the second one. So we're going to go cloud environment use env-nj5dv. And there we go. It set our default environment. So when we run that command where we check for our cluster list, we just run that again, cluster list. Oops, C Cloud Kafka cluster list. My bad. It should show you, yep, that cluster right there. So what we can do now is C Cloud Kafka cluster use LKC-2PW50. And now we're using the correct cluster. So if we run that command again, it should just work. There we go. We've set it for user gain. We can also set it for user losses. Boom. That's exactly what we wanted done. So what changes have we made to our project so far? So if we go to our project directory, if you go to stack configs, you will find that now there is a configuration file in here. This configuration file is for Terraform to use and provision its resources, and so that it knows where the cluster is and has the correct access keys for it. So if I open this up, you'll see that this has all the connection mechanisms and tools present inside for, well, our game to connect to our Confluent cluster. So it tells you what the environment ID is, your service account ID, your Kafka cluster ID, and down you have the bootstrap servers, your schema registry URL, your KSQL endpoint, all of it. It's basically just a passport for your Confluent Cloud cluster. So I'm just going to close this, come back to our Ubuntu terminal, and now I'm going to run start again. But this time, it's not going to do all this process over again. It's going to run Terraform and set the game up for us. So let's see how that works. There we go. Terraform has been successfully initialized, and now it's going to go ahead and set up the game for us. There we go. It's done running, and at the end, all it's done is it's given us this output that says that this is the link you can visit to play your Pac-Man game. So let's copy this link over, open a new browser tab, and visit the link. As you can see, the game's working perfectly fine. So I can just call it skill curve and move on. Yep, classic Mario music, but it's a lot of noise. So I'm just going to generate a bit of a score here, and then we're going to go straight to our Confluent cluster to see what's going on. So I think 11, there we go, 1300. That's a good score, right? 1420. So I now have a score of 1420 on this person that I've called skill curve. We're still on the first level and we've got 2 lives to go. So where is this information? How is this being propagated? So first, actually, let's look at the scoreboard, I suppose. Let's look at the scoreboard to see what's going on. So you can see that on the first rank is skill curve with a score of 1420 that's on level 1 and hasn't even lost yet. So if I go back to the game, actually, to generate a loss, I would have to completely lose out on a level. So let's see what happens when I completely lose out on a level. So I can just feed myself to, okay, this one. And then just feed myself one more time. And one more time. And then that should be game over. There we go. Game over. I lost. So now if we go back to the scoreboard, nothing would have changed here. Of course it wouldn't. But all you would see is that now I have 1 loss associated to my skill curve account. So if we go back to the Confluent Cloud and we go over to streams, we can actually see how this is working in real time. So if we go to user game, we query the stream. So we say that we want it from the earliest. It's already running a query, so I'm going to stop it and I'm going to rerun this query. And all of a sudden, it gives you all this information. It just got that message that I just died with a score of 0. Oh no, actually, it's got the message that I'm going to restart. Never mind. But yeah, you can see all these messages being propagated and being sent forward through our stream. And if we go to the other stream, which is user losses, this is going to be a bit more of a dull stream. It's not going to be much here. Yep, just that this user, skill curve, just lost. He just lost. Added to the tally. If we go over to the tables, we can see that we got stats per user and losses per user as per the usual. So if we query this table for the earliest, we can see no new messages. Oops. Yep. That was scary. But yeah, this is exactly what it should be showing you. Is that you have a user skill curve with the highest score of 1420, the highest level that it ever got was 1, and the total losses it has is 0. So if we go back to our tables and we look at losses per user, we can query this table. Let it run for a second. And yeah, it'll show you that you have one user right now, skill curve, with a total loss count of 1. You have completely lost once. And lastly, we have a summary stats table, which if we query this table, let's see what we get here. We get, well, basically this. We get a summary key, the highest score value, and the user who set the value. And with that, you have successfully run an event streaming application through Pac-Man. But before I forget, we do have to stop this project. You have to remember this is using up resources. So what we're going to do now is just stop everything. So we're just going to run the stop.sh command. And this command is going to completely destroy all the resources, including the Confluent Cloud environment that you just set up, so that you don't get charged any more than you need to for running this demonstration. This is going to take its time, so I'm just going to pause here and come back when it's done. And there we go. Everything that we made, everything that we set up is now completely destroyed and gone. So if we go back to our S3, we can see that now there's no buckets inside here. There was a bucket here temporarily while we were running Pac-Man. Now it's gone. And whoops, can't connect to the application. I wonder why that is. Because if you go back to your environments, the environment's gone. The entire cluster is gone, deleted. And I would advise you do run that stop script if you don't want to run your build too much for the resources you're going to be using. But yeah, that's about it for this demonstration. I hope you enjoyed. And if you like what you see here, then please do feel free to subscribe to the channel. And if you have any questions or concerns or queries about this demonstration or any demonstrations that you see on the channel, please do feel free to drop a comment in the comment section below. It's been nice. Have a nice day. Goodbye.